And as I keep saying, when the US wakes up to the energy transition, which the Inflation Reduction Act is a clear, signal of, it is probably the best incentivizing inflation reduction, incentive on the planet right now. And it's meant to reduce energy costs, right? And it's meant to accelerate the energy transition at the same time. But what I think, the listeners should be attuned to is that if we aren't able to reduce the costs of energy, it's going to be very hard.
If you're a clean energy professional, you need to know about energy storage. Today, my guest is Tom Jensen. He is the CEO of a Norwegian battery company called FREYR. Welcome to the show, Tom.
Hey, Tim. Pleasure to be here. It's an honor, of course, to speak to like-minded people.
It's as I like to say, it's very heady days. We have the Investment Reduction Act legislation, which is spurning tremendous growth in manufacturing here in the U.S. You're there in Northern Europe, but making partnerships all over the globe. Tell us about your background and how you came to the lithium-ion industry.
So Tim, my name is Tom Jensen. I'm Norwegian, so don't hold that against me. And I'm an economist by training, unfortunately. And I say that a little bit deliberately because for the last 15-ish years, I've been working on scaling disruptive technology, broadly speaking, in the sustainability space, with a core focus on renewable energy. So anything sort of renewable energy technology related has sort of crossed my desk over the last 15 years. Prior to that, I was in the Norwegian oil and gas and aluminium industry, as most sort of professionals in Norway tend to have sort of been there at one point or another. So back in 2017, an old colleague of mine from Norsk Hydro, the company from where I sort of grew up commercially, called me up and said that he had this idea of establishing gigafactories of battery cell manufacturing in Norway. And that sort of fit the mark for me. It's renewable energy, it's new technology, it's how can we scale it, leveraging Norwegian advantages, et cetera, et cetera. So we started out with sort of a big look in the mirror where we asked ourselves, does it really make sense to set up gigascale manufacturing capability in the Nordics? And of course, we were inspired by Northvolt, our Swedish friends. Mm-hmm. And we think in Norway that if the Swedes can do it, we can do it a little bit better. That's kind of how we a little bit get this competitive tension on board. But joking aside, very much inspired by them and impressed by what they've accomplished. But more importantly, we looked at what does Norway have to offer. And Norway has, at least in several pockets of the country, large untapped renewable energy production capacity, which means that you can get access to power island-based prices, low-cost green electricity for a manufacturing setup which is energy intensive. So that was kind of one tick mark that we wanted to sort of make. The second is that Norway, for the last century or more, have actually been producing energy and energy-intensive products in various forms and predominantly exported this to the world. Norway is a small country, but we pride ourselves in sort of being very good at producing energy in various shapes and forms. And that was kind of the second thing. This means that we have a labor force which is very well educated and knows how to build mega projects in very harsh terrains and in very harsh environments, I should say. If you go offshore Norway, where there are more than 100 oil and gas platforms, you kind of know what I'm talking about. So actually doing that with quality, at scale, at pace, with the safety requirements required, that provided a bit of a good mix to sort of start thinking about becoming a battery producer. Then what we said is we find it reasonably hard to consider replicating, quote unquote, the Asian large-scale battery manufacturing, let's call it model. And doing so in a Western hemisphere environment, then you need some really clever comparative or competitive advantages to be competitive over time. So we spent quite a long time deciding on our initial technology strategy. And what we, Tim, were looking for were three things. So we were looking for a technology that was commercially introduced because we didn't want too much technology scale-up risk. There are many next-generation battery cell technologies out there that are struggling to sort of scale up capacity, and we wanted something that was already commercially in the market. The second thing we were looking for was something that offered step change in performance and cost when produced at gigawatt hour scale. And the third thing we were looking for was something that could continue to improve over time so that we can move into the future with a perspective of continued improvement in performance and cost. And when you apply those filters, Tim, to the global battery landscape, there aren't that many companies left standing, or there weren't, at least in our opinion. And the one that stood out in the crowd for us was a US-based company called 24M Technologies, which we can come back to in a second. But when we then figured that we had access to licensing in or partnering with a technology company that is 12, 13 years in the making, MIT spin-off out of the US, with a Norwegian, let's call it vantage point, with the benefits that I just spoke about, those ingredients, if you like, gave us real confidence that there is something here. And since then, we've gone public on the New York Stock Exchange, which we did mid-2021. And we have built an organization which is now reaching close to 350 people. We have announced our Giga Arctic development in northern Norway. We're soon to complete our initial industrial scale production line in what we label the customer qualification plant in the same location, where the 24M technology will be put in production later this quarter at gigawatt hour scale manufacturing size. And then also last year, we announced that we were going to replicate what we're doing in Norway in the US, more notably in Coweta County in Georgia, where we're going to also build a gigafactory based on the same technology. So that is in short, Tim, who we are and what we've done so far. And we're very excited about the progress and happy to sort of go into the conversation.
So what is the basic business model? It sounds like you are at your core a manufacturer. You're leveraging the technology of 24M. Tell us what is their technology, and then why does 24M need FREYR?
So 24M is a technology developer, so let's call it an R&D setup that have developed what they label next generation lithium-ion battery production setup, or they call it the semi-solid production platform, which is not really halfway to solid state, which many would sort of think. It's more to the texture of the mix of the anode material and the electrolyte. So it's kind of a clay-like substance. But what is very interesting about 24M is that they decided early on when they started developing this, and as I said, this is an MIT spin-off that was started in 2009 by a renowned material science professor at MIT, Professor Jetming Chang, who basically said, hold on, the lithium-ion batteries introduced in 1991 were predominantly introduced for handheld devices, so small-ish devices. Because everyone wanted a computer or a camcorder or an iPhone or whatever it might be, lithium-ion batteries at that minuscule scale, I should say, were scaled quite significantly with supply chain cost reductions following with it. And then at some point in the sort of late last couple of decades, prices of these batteries came so competitive that it was starting to become relevant to think about putting these batteries into electric vehicles. And then after that, it started to become relevant to use the same batteries for energy storage, even though the batteries themselves, Tim, were not developed for that purpose at all. So the point being with 24M is that they said there has to be a better way to both design a battery and to produce a battery for the purpose now in which it's going into, i.e., decarbonizing transportation and decarbonizing energy systems globally. So that's basically what 24M has done. They've redesigned the way in which the battery is designed and the way in which the battery is produced, offering dramatic reduction in footprint for the production facility with resulting significant reduction in capital expenditures, a very large reduction in energy consumption, and much fewer employees per gigawatt hour of battery produced, but using the same raw materials as conventional lithium-ion battery producers use. So it's kind of a step into the future, but staying in the present, so to speak. Mm-hmm. And we believe this is a big, big step forward. And the batteries are much more suitable for energy storage applications, but also for e-mobility and electric vehicle applications. We as FREYR decided to start with the energy storage application first because most other battery players are targeting the booming EV space. But we have always been of the opinion that energy storage is going to be an as large market as the electric vehicle market, because when you deploy 20 times more solar and wind, which is what we require to do if we're going to decarbonize the energy systems, you need 200 to 500 times more storage applications than what is installed today. And the only currently available cost-competitive solution to that is lithium-ion batteries. 2-hour storage, 4-hour storage, 8-hour storage, all possible with current lithium-ion battery technology. And again, the 24M technology is particularly better suited for it because it has a dramatically lower, let's call it, cost footprint and significantly larger batteries at that. And the final thing I'll say then is, if you think about a container, which is typically what you're thinking about when you store the sunlight being generated from the panels beneath you, they will be put into storage facilities when you're not requiring that energy and then dispatching that energy from these containers when you actually need them. And if you put a lot of small batteries into these containers, there's just so much wasted space. There's so much waste in terms of non-energy carrying material, which basically the 24M solution enables you to eliminate. So there's a much higher ratio of energy carrying material to the final volumetric, let's say, product in the container. And that basically allows you to store a lot more sunlight for the same amount of investment.
Is it a pouch form factor, or what is the form factor?
So we can produce both pouch and prismatic form factors. Our initial focus are going to be pouch, and because of the larger structure of the battery and also the way in which it's produced, which is a much safer solution and also a much more recyclable solution at that, it does also allow us to provide much better system level effects. So that means because the battery is bigger, you need less, let's call it, supporting materials around it, because you just have much fewer unit batteries. So you have fewer modules, you have fewer racks, you have fewer packs, you have less wiring, you have less of everything that today you require a lot of because the batteries are so small. In addition, when you have thicker and larger electrodes, you can pack a lot more energy carrying material inside one battery cell itself, and you can serially sort of connect them, which allows you to also optimize the total configuration at the system level. So not only are you having a cost saving at the battery cell level, you're also having dramatic cost savings at the battery pack, or let's say container level. And if you're then moving fast into that area with some of the brightest partners in that field, we believe we can really sort of drive down cost for energy storage using 4-hour lithium-ion battery solutions, to put it simply.
And, I'm aware of this because I have strong ties to Norway, but the Norwegian grid is already decarbonized. It runs on hydroelectric power largely. And, of course, you're also an early adopter of offshore wind. You're a major oil producer with Equinor. And you mentioned Hydro, a major industrial company in the aluminum space. So heavy industry is no stranger to Norway. So that all sounds good, right? You have clean energy, and an industrial base. So no problem setting up a big factory there in northern Norway. You're setting up in a city called Rana. I can't.
Mo in Rana.
Mo in Rana, yes.
Mo in Rana, so both is right. Yeah.
So that's all well and good, and I love this partnership with 24M. But what is it fundamentally then that FREYR is bringing besides this? Okay, you've got clean energy and you've got industrial know-how. Is that it, or how is it that you're taking on the Northvolts of the world and adding value to the industry, value and volume?
We should look upon this as kind of an orchestration of a very complicated value chain, right? So we all come from upstream-based businesses. Most of the people in FREYR are Norwegian industrial people, at least on the project execution and operational excellence side, that have actually sort of known how to extract raw materials and turn them into the finished product. Now, if you think about the lithium-ion battery value chain and a NMC-based battery or an LFP-based battery, here we're talking about 12, 13 different inputs that need to go into a fairly sophisticated high-speed manufacturing process. And therefore, you need to be very skilled at finding the best providers and or technology partners on the upstream side. So this is also something that we're spending quite a lot of time on, Tim. We are teaming up with the best on the lithium processing side, the best on the LFP side, the best on sort of recycled, other materials, etc. We are also considering to set up our own cathode manufacturing plant, as well as sourcing cost-competitive materials from existing providers in the space, all of which we're going to do with renewable energy. And we're going to then build these facilities a little bit better and a little bit faster and operate them a little bit better than everyone else. And we're going to do that in a partnership-based approach, because we don't think, if you want to enter into this space, again, competing with largely the Asian setup, you need to do something different. If you're going to build out all of these capabilities yourselves from the get-go, it will take us a too long time to become relevant in the market space. Mm-hmm. So therefore, we said there is a massive market short on the horizon. Demand far strips, supply. And especially if you put into the equation that both Europe and the United States, and for that matter, most countries around the world, will largely want these kind of input factors to be produced close to home. And if you add that on top of the equation, you actually need to set up something local that can deliver products fast, but that can also be competitive against relying too much on the Asian production in general, and maybe the Chinese production in particular. So when you put all of these things together, there seems to be, and we have at least recognized and seen that very massively in our marketing of our solutions, there is a very strong demand for localized production of batteries using somewhat similar solutions as what is provided from Asia today, but offering also a competitive advantage in terms of decarbonized footprint of the battery, which largely is about what power source you use, both on processing the upstream materials as well as the battery cell itself. Mm-hmm. And that is really what we sort of, figured out early that we wanted to do. Differentiated technology, differentiated location of production, differentiated carbon footprint, and doing it in a partnership-based way. So we partner with our customers, we partner with our vendors, we partner with our suppliers, and we create this ecosystem-based approach of really taking this to massive gigawatt-hour scale, with the opportunity to replicate that gigawatt-hour scale rapidly in multiple jurisdictions that require decarbonized, decentralized, and localized production of what needs to be scaled to hundreds, if not thousands and thousands of gigawatt hours. I mean, our perspective on this is ultimately a industry that cranks out 20 terawatt hours of batteries annually. If the world is going to decarbonize roughly in line with the Paris Agreement, our view is that the world is going to need about 300 terawatt hours of batteries produced. And if you take that over a 15-year time frame, then you're coming to sort of a 20 gigawatt hour annual consumption. And 15 years is roughly, I guess on average, the time frame in which the batteries kind of last. And when you then come to the end of life of those batteries, we will have recycled solutions for most of the black mass or the raw materials that exist in these batteries. Yep. So all of this we have tried to put together in sort of a consistent value proposition, and it's triggered a lot of interest, Tim, I have to say.
Yeah, I mean, it sounds like it. You have made, I noticed, a deal with Powin, a well-known ESS company here in the U.S., and the fact that you're propping up a factory in Georgia means you're, really serious about this. How do you solve the clean energy problem in Georgia? Georgia's not particularly well known for having a lot of renewable energy. I mean, there are some utility scale solar farms being built there, but what's the answer to green energy in Georgia?
So I guess the answer to clean energy in Georgia is the same answer to clean energy in the United States in general. I mean, the power mix, if you look at U.S. broadly is still largely non-renewable. Of course, there are certain pockets in the US where you have a lot higher renewable energy penetration than others.
Yeah.
But we go into this, again, we have 3 dialogues with 3 different utilities. We have multiple dialogues to develop our potential own dedicated solar plus storage plant for the facilities that we erect. And there are many examples around the world of dedicated solar plants plus storage that, replace baseload energy generation. And this becomes behind the meter energy. So you're not subjected to tariffs and all of those other things as well. So when you put all of these pieces of the puzzle on the table and you have an open book, in a way, approach to the utility companies locally, you would be surprised to see how many of them are very interested to sort of have 100% renewable energy supply in a reasonably short order. So if the US, driven by the Inflation Reduction Act, as you mentioned initially, is going to sort of meet the objectives of decarbonizing the US industrial sector, huge amounts of renewable energy will need to be deployed. And, by the way, the main products that we produce will catalyze that, because we are going to create the storage medium that allows for a much faster deployment of these renewable energy, parks, whether it's combined wind and solar, or whether it's dedicated solar development. All of them are going to need storage facilities to balance out the intermittency of that renewable energy. But we are not too worried about this, but it's a core focus of us, because it's the core sort of one of the core promises that we make is that we are going to create and build and deliver the cleanest battery solutions on the planet. And we are hard at work trying to do that, even in Atlanta, Georgia, or south of Atlanta, I should say. And, solar installation in that area is reasonably decent. But let me just give you one example, and sorry to rant on about this. A reasonably large industrial facility in the southern parts of Norway, which is at the level of Anchorage, for those who don't understand, how much north it is, solar rooftop plus storage for that facility generates a power cost to that entity of $45 a megawatt hour. That far north, average across the year. Okay? So if you then go further south, as of course Georgia is, you can envisage dramatically lower 24/7 energy supply than that. And that is really what is happening. And I don't think people fully recognize the speed at which this, transition is happening. And it's in that kind of wave that we would like to be, let's call it one of the leaders, at least in the clean battery solution space.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and a review. Back to the show. Yeah, the cost of large-scale wind and solar power is sub 3 cent in the U.S. and many times sub 2 cent. So it's very competitive. Not that that's everything, right? We have to focus on decarbonizing the economy, period. And so I love it that is fundamental to your mission. You mentioned a very big number, 300 gigawatt hours. I love it. When folks like yourselves lay out what is the plan to decarbonize the grid globally and electrify transportation and electrify industry. I mean, we are going to triple the grid when we electrify industry and transportation. That's a lot more electricity we're going to need. And of course, that comes along with storage, because wind and solar are intermittent. And so it's a perfect pairing. But those 3 technologies combined very clearly now can really solve the problem per se. We don't have a technology problem. We have a deployment problem. And it is game on to see how quickly we can build these gigafactories and bring them to market. As far as your go-to-market, who is going to be buying these FREYR systems? And you've mentioned both transportation and stationary storage. They're both huge markets. Initially, the EV market is going to be bigger, but yes, the stationary storage market is going to catch up and be just as big. And so they're obviously both huge market opportunities, but are you literally, is it a both and, or are you going after stationary first, or what is your approach?
So we were going after stationary first. We have signed up more than 130 gigawatt hours of initial offtake agreements. The most, let's call it the largest one, and the one we have spoken about the most to the market so far, is with a company called EDGE Corporation, which is a Japanese powerhouse, the largest producer of electric motors globally, and also one of the larger energy storage deployers and developers on the planet, with more than 130 energy storage projects in the US and Europe and other places. So that's a 38 plus 12 gigawatt hour contract, which we've already signed and announced. And they're also our joint venture partner on creating, let's call it the DC blocks. So basically the containerized solutions of the battery cells that we are producing first in Norway and then subsequently in Georgia. Now, we are on the verge of announcing agreements in the electric mobility space, as well as advanced progress with the electric or the more traditional OEMs in the EV space. So there is absolutely no shortage of interest from across the board of the solutions that we can provide. But we wanted to go down the route of where the relative advantages of our technology were the absolute greatest, and that is in the energy storage space. The advantages are also significant in the EV space, but it's also a space where competition is much tougher and, the space is more crowded. But having said that, now that we have sort of gone the other way, we went the ESS to EV route as opposed to the EV to ESS route. We started with LFP cathode materials first, as opposed to NMC material, which many others sort of started with. So far, knock on wood, we seem to have sort of hit the mark in a good way. We try to sort of sign up as much long-term sales agreements into our facilities as we have to, but not more, because we do believe that over the coming decade or two, there is going to be a huge shortage of batteries, especially when you add requirements of localized supply. And therefore, being fast in developing low carbon, cost competitive, fit for purpose battery solutions close to home, so to speak, is resonating across all market verticals, Tim. And you should just pay attention to what we're doing. There's going to be a lot of news coming out of where we are. First batteries will be produced at industrial scale in our customer qualification plant in a matter of months. And therefore, we're very excited about what 2023 have in store. And that really is a pivotal moment for the company coming into gigawatt hour scale production.
So when you look at NIDEC, NIDEC, nidec-industrial.com, for example, is one of their websites, you see these storage containers. And is the ESS solution going to have a NIDEC logo on it or a FREYR logo on it?
So this joint venture that we've established with them is a NIDEC-controlled entity. We have a minority position in that joint venture. The important thing for us is, again, to partner with those who actually have done this before and know how to do it. So they have a supermajority. We have 1/3, they have 2/3. So that means that we have teamed up with a excellent ESS provider who and that joint venture then are buying large amounts of battery cells from a facility that FREYR control 100%, because we wanted to focus on producing the battery cells themselves and not the final product, at least not initially. And then now we're sort of thinking about other solutions, domestic storage facilities, behind the meter solutions for commercial and industrial, as well as utility scale kind of focus, which is really the focus we have with NIDEC. So there is a lot of opportunity for us to sort of tailor make our battery cells into modules and packs that fit for other market verticals. We potentially and probably will do more of that also with NIDEC, but there is so much ground to cover, literally, that we sort of, keep an open mind. And having this let's call it industrialization partner of choice philosophy, as we have been talking about a couple of times now, is resonating with a lot of these stakeholders, because these are large projects and sort of diversifying risk and taking, partnership-based approaches is part of mitigating the capital exposure and mitigating the risk for large capital exposure across multiple facilities. And final thing I'd say is many of the companies and the customers that we have are global entities that deploy projects globally, but having supply of these key inputs from a multi-geography perspective, which we label geographic diversification, hence both Norway and the US, but also other locations that are in the making, is something that, a viable and sustainable battery producer will have to do, in our opinion. You cannot rely on exporting battery solutions too far around the world. It's not particularly environmentally friendly, especially not until you have figured out long-haul transportation in a decarbonized way, even though we think that's going to come faster than most people think, even, supported by electric solutions. But in any way, decarbonized, decentralized, localized production is about energy security. It's about critical energy infrastructure. And all of these things, is what we are trying to fit into our business model.
So the products rolling off your line, though, initially are going to be battery cells?
Correct.
Yeah. And that makes sense then that you're partnering with companies like Powen. They're going to put it together into a containerized solution.
Correct.
And the same with NIDEC then, right?
Correct. And with NIDEC, we are partnering with them in a joint venture so that we learn from someone who's actually done this more than 100 times, right? How to actually build these things in the most proficient manner. Yeah. And then we mix and match, and we learn from them and they learn from us. And then we optimize the total system so that we can drive down the system level cost. Because at the end of the day, what the utility company is preoccupied with, or the industrial commercial company that wants, behind the meter solution, is the cost of the final product. And it's the levelized cost of energy over the lifetime of, the duration of the batteries that really matter at the end of the day. And we can provide a dramatic reduction in that over time.
Yeah, and Georgia is certainly in the news a lot, both auto manufacturing, solar manufacturing, battery manufacturing. So those cells won't be going too far, a couple 100 miles perhaps, to find a home in a container or in a electric vehicle eventually. And that's absolutely, right. You want to make the batteries as close to the end product as possible. Big heavy stuff.
Absolutely true. Exactly. Can be moved with electric trucks, by the way, which also can be charged with renewable energy, balanced by storage. So this is becoming this virtuous circle, right?
Sure.
When you start to get more and more of these things, costs come down, availability comes down, range anxiety comes down, all of the elements that sort of historically have been speaking against a faster deployment. This is why this is not linear, right? This is exponential. It is moving a lot faster than most people think. Yeah. We're in the early phase of that S-curve. And of course, that's when it's most painful, but it's also when it's most interesting, to put it that way.
Yeah, we're certainly at the tipping point now. In 5 years, the ICE engine will be a minority of new car sales, for example. You don't see it today, right? They're still less than 2%, I think, of auto sales in the U.S. They're 80+% in Norway, right? The Northern Europeans are 10 years ahead of the U.S. in terms of making the energy transition. I like to say, if you want to see the future, go to Northern Europe or go to China in many respects. China also has been going hard after the energy transition. They're an ironic both and in that they're also building coal plants, which is just a travesty, but they need so much power. I guess they feel like they're forced to rely on their own native source of energy. So they have massive fossil fuel reserves as well. But so what else should our listeners know, Tom, in the last few minutes together here about FREYR? It's FREYR. It doesn't exactly roll off the American tongue, but it doesn't have to, because you're really not going to be a household brand. You're selling to other industrial partners. You're not trying to be a Tesla per se, although you are going to compete with Tesla because Tesla is a battery cell manufacturer. And that was, you see the visionary in Elon Musk, right? Vertically integrating the way he has done is so vital because battery cells are a limiting factor. If you're an EV maker or an ESS stationary solution provider, right, you need access to gigawatts and gigawatts of battery cells. And it's totally non-trivial.
It's totally non-trivial, but at the same time, it's an industrial process, right? It's a complicated electrochemistry, but at the end of the day, it's math. And as I keep saying, when the US wakes up to the energy transition, which the Inflation Reduction Act is a clear, signal of,
yes,
it is probably the best incentivizing inflation reduction, incentive on the planet right now. And it's meant to reduce energy costs, right? And it's meant to accelerate the energy transition at the same time. But what I think, the listeners should be attuned to is that if we aren't able to reduce the cost of energy, it's going to be very hard. But battery solutions combined with renewable energy solutions are already, in many, many places around the world, lower cost than its fossil counterpart. And the electric vehicle is already, for many, many models and many, many use cases, already cheaper than the combustion engine counterpart. And this is only going to continue because it's only in the early days of its transition. And back to my original point, as the US really wakes up to this, the capital forces, the brain power, the sheer size of the market, and the sort of capitalistic interest in deploying lower and lower cost solutions and better solutions will just, take a foothold in that acceleration. And therefore, we are always of the opinion, have always been of the opinion that we need to be in the US to be relevant in this market. 5 to 10 years from now, nobody's going to recognize where the US market is relative to any prediction that is out there right now. Because once it starts moving, it moves at a pace that no other market will. So in our humble opinion, the US will be the energy transition leaders in the not so distant future, which is kind of an interesting perspective to have, because right now they're not necessarily seen as the country that sort of is driving the energy transition, but that is changing. And the Inflation Reduction Act is a core catalyst to that. So I say to European politicians and to Norwegian politicians, look to the US. If you want to accelerate the green shift, as we call it here, look to Washington. They know how.
Well, it's great to hear a European say that. So thank you. And thank you to the Biden administration for really leaning in and creating wonderful industrial policy. We see the power of industrial policy. It's so vital. This is good paying jobs, long-term economic growth, and cleaning the grid. It's a completely virtuous cycle. It has to happen. It's not a question of if, but how fast, right? And can we do it fast enough? I mean, you and I are going to be fine, Tom. We're not going to see the worst of climate chaos, right? But our children and our children's children are in for a world of hurt and change and drama. And we just want to do our best to soften that landing, right? That is my mission, to speed the energy transition. And I do this for my grandchildren and future generations. So it's so great to see you guys doing what you're doing. I laud you, and I'm grateful for your time this morning. How can our listeners find you, Tom?
You can tune in at www.freyrbattery.com. We're also listed on the New York Stock Exchange under ticker FREY. So just Google FREYR, and there will be, a gazillion hits already. So we should be easy to find.
Excellent. And you can find all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify so that others can find this content. Please subscribe to our YouTube channel as well. Just click on the YouTube icon at cleanpowerhour.com. I'm Tim Montague. I want to thank Tom Jensen for coming on the show today. Let's grow solar and storage.